Okay, in the last class, I had taught you how to calculate the atomic number, mass number, number of protons, number of electrons, and number of neutrons. So let's revise, and after that I'll teach you something new. Let's take Na, that is sodium. So according to the formula that I have given, mass number, that is A, equals to 23. Atomic number, that is Z, equals to 11. I have told you atomic number is always equal to number of protons, which is in turn equal to the number of electrons. So atomic number is 11, the number of protons is also 11, number of electrons is also 11. So number of protons equals to 11, number of electrons is also 11. Now we come to the number of neutrons. The formula is mass number minus number of protons. So 23 minus 11, which is equal to 12. So we had done till here. Now we have learned something new that is known as electronic configuration. Electronic configuration is the arrangement of electrons in the orbit. Now the electrons are not placed anywhere in the orbits. They follow a certain formula, which is 2n square, but I will not be teaching you this formula right now. We'll be doing it in an easier method, okay, since you all are just learning about it in class 6. Okay, so first orbit, which is also known as the K orbit, will always have a maximum of 2 electrons. So the first orbit can hold how many electrons? Only 2 electrons. Second orbit, L, will have a maximum of 8 electrons. Third orbit, M, will also have a maximum of 8 electrons. Fourth orbit, N, will also have a maximum of 8 electrons. So this carries on. Okay, so first orbit will have a maximum of 2 electrons, and after that all the orbits will hold a maximum of 8 electrons. And what are the names of the orbits? K, L, M, N, O, P, Q, and so on. So actually this formula is used, but I will not be explaining this. You'll do it in the higher classes. Okay, so the next rule, this was the first rule. First rule was first orbit can hold a maximum of 2 electrons, and then after that 8 electrons. Now we come to the second rule. The second rule is, without filling in the first orbit, I cannot jump to the second orbit. Without filling the second orbit, I cannot jump to the third orbit. And similarly, without filling the third orbit, I cannot jump to the fourth orbit. So each orbit has to be completely filled to go to the next orbit. So let me do it. Number of electrons in sodium is 11. So number of electrons is 11. So let's do the electronic configuration. So I told you first orbit, that is the K orbit, will have how many electrons? Maximum of 2 electrons. So out of this 11, the first orbit will have 2 electrons. Second orbit. So out of 11, 2 are here. So 11 minus 2, how many left? 11 minus 2, 9. So how many electrons left? 9. Now, second orbit has how many electrons? 8. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 9 electrons. So all these electrons are filled in. So in the second orbit, we have 8 electrons. How many left? 1. So the last orbit will have only 1 electron. So I filled in the first orbit. Then I went to the second orbit. The second orbit could hold 8 electrons. So I placed 8 electrons in the second orbit. Then I jumped. Then I went to the third orbit. Third orbit also can hold 8 electrons, but only how many electrons are left? Only 1. So 1 orbit will be there in the third orbit. Okay, so the arrangement of these electrons in the orbits is known as electronic configuration. The electronic configuration follows the rule of 2n square, which we did not do this time. I taught you all in a simple way. First rule, the first orbit, that is the k orbit, will have 2 electrons, and from the second orbit onwards, maximum of 8 electrons. It can have less than 8 but not more than 8. Then the second rule, without filling the first orbit, I cannot go to the second orbit. That means I cannot write only 1 here and then go to the second orbit. So first I have to fill the first orbit, then only I can go to the second orbit with the remaining electrons. Once I fill the second orbit with the remaining electrons, I go to the third orbit and so on. So here number of electrons was 11 for sodium. So the first orbit, that is K, first I'll fill it. How many electrons can it hold? Only 2 electrons. So I place 2 electrons here. Out of 11 minus 2, I'm getting 9. So with 9 electrons, I go to the second orbit. Second orbit can hold a maximum of 8 electrons. So out of 9, I place 8 electrons in the second orbit. So how many electrons are left? Only 1. So with 1 electron, I go to the third orbit and I place it there. So the electronic configuration becomes 2, 8, 1. This is how we write. Let's try another example. Magnesium 24, 12. So the formula XAZ. This is the second example. Mass number A is 24. Atomic number Z equals to 12. We know atomic number equals to number of protons, which is equal to the number of electrons. So this will become 12, 12, 12. That means number of protons equals 12. Number of electrons is also equal to 12. Number of neutrons equals to mass number minus number of protons, which is equal to 24 minus 12. So the number of neutrons is also 12. Now we come to the electronic configuration. So electronic configuration is the arrangement of electrons. So how many electrons are there? 12. So first orbit, that is K, maximum of 2 electrons. So not more than 2. So out of 12, 2 electrons in the first orbit, I go to the second orbit with 10 electrons. So out of 10 in the second orbit, how many electrons can be there? Only 8 electrons. So 10 minus 8 equals to 2. Only how many electrons left? 2. So with 2 electrons, I go to the third orbit and I place it here. So the electronic configuration becomes 2, 8, 2. Okay, one more example. Let's do carbon. So X, A, Z. Mass number, that is A, equals to 12. Atomic number Z equals to 6. Atomic number equals to number of protons, which is equal to the number of electrons. So atomic number is 6, so number of protons is also 6, number of electrons is also 6. Now we come to the number of neutrons. Mass number minus number of protons, which is equal to 12 minus 6. The number of neutrons is also 6. Next, electronic configuration. So how many electrons are there? 6. So K, first orbit only 2 electrons. So out of 6 electrons, I place 2 in the first orbit. So how many left? Only 4. So I go to the second orbit with 4 electrons. Now in the second orbit, I can place 8 electrons. So 4 electrons. All the 4 electrons will be placed in the second orbit. I have told you, without filling the second orbit, I cannot go to the third orbit. I cannot write 2 here and go to the third orbit. I have to fill the second orbit first. So to fill the second orbit, I need 8 electrons, isn't it? So all these 4 electrons will be placed in the second orbit. So the electronic configuration is only 2, 4. So please remember the rules. First orbit, maximum of 2 electrons, and then from the second orbit onwards, a maximum of 8 electrons. Without filling the first orbit with 2 electrons, maximum of 2 electrons, I cannot go to the second orbit. Without filling the second orbit with a maximum of 8 electrons, I cannot go to the third orbit. Without filling the third orbit, I cannot to be filled. Then only I go to the second orbit with the remaining electrons. Like here, first orbit 2. So out of 11 electrons, 2 were placed in the first orbit. So how many left? 9. So with these 9 electrons, I go to the second orbit. And 8 electrons can be placed in the second orbit. So how many left? 1. Then only with the 1 electron, I move to the third orbit. I cannot fill here with only 6 electrons or 7 electrons and go to the third orbit. No, I have to fill the second orbit to move to the third orbit. So I hope you all understood what we did today. Thank you everyone. Bye-bye.